Hello students, my name is Arshan and today we'll do the 13th chapter from class 7th Science NCERT textbook, and the name of the chapter is Motion and Time Part 2. So students, in previous part we learnt about different types of motions. We learnt about speed and its unit and also the measurement of time and distance as well. So let us start this chapter with our topic, that is measuring speed, and let us commence with this activity, that is activity 13.3. Activity 13.3. Draw a straight line on the ground with chalk powder or lime and ask one of your friends to stand 1 to 2 meters away from it. Let your friend gently roll a ball along the ground in a direction perpendicular to the line. Note the time at the moment the ball crosses the line and also when it comes to rest, just like it is shown in this figure. Now, how much time does the ball take to come to rest? So students, we'll measure the distance between the point at which the ball crosses the line and the point where it comes to rest. So you can use a scale or a measuring tape. Let different groups repeat the activity and record the measurements in table. Now in each case, calculate the speed of the ball. You may now like to compare your speed of walking or cycling with that of your friends as well. You need to know that the distance of the school from your home or from some other point, and each one of you can then measure the time taken to cover that distance and calculate your speed. It may be interesting to know who amongst you is the fastest. So students, speeds of figure or measuring the speed of a ball or some living organisms are given in table 13.4, that is in kilometer per hour. You can calculate the speeds in meter per second yourself. So well, do you know students, the smallest time interval that can be measured with commonly available clocks and watches is 1 second. However, now special clocks are available that can measure time intervals smaller than a second. Some of these clocks can measure time intervals as small as 1 millionth or even 1 billionth of a second. Now you might have heard the terms like microsecond and nanosecond. 1 microsecond is 1 millionth of a second and a nanosecond is 1 billionth of a second. Clocks that measure such small time intervals are used for scientific research, and the time measuring devices used in sports can measure time intervals that are 1/10th or 1/100th of a second. On the other hand, times of historical events are stated in terms of centuries or millenniums. The ages of stars and planets are often expressed in billions of years. Now, can you imagine the range of time intervals that we have to deal with? So, rockets launching satellites into Earth's orbit often obtain speeds of up to 8 km per second. On the other hand, a tortoise can move only with a speed of about 8 cm per second. So, can you calculate how fast is the rocket compared with the tortoise? So students, once you know the speed of an object, you can find the distance moved by it in a given time. All you have to do is to multiply the speed by time. Thus, we get the formula, that is, distance covered is equals to speed multiplied by time. You can also find the time an object would take to cover a distance while moving with a given speed. So, time taken is equals to distance divided by speed. Now you might have seen a meter fitted on top of a scooter or a motorcycle. Similarly, meters can be seen on the dashboards of cars, buses and other vehicles. Now this picture shows the dashboard of a car. Note that one of the meters has written kilometer per hour at one corner. This is called a speedometer. It records the speed directly in kilometer per hour. There is also another meter that measures the distance moved by the vehicle. This meter is known as an odometer. So while going for a school picnic, Paheli decided to note the reading on the odometer of the bus after every 30 minutes till the end of the journey. Later on, she recorded her readings in this table 13.5. Now, see this table students. Can you tell how far was the picnic spot from the school? Also, can you calculate the speed of the bus? So while looking at the table, Bujo, one friend of Paheli, has asked Paheli that whether she can tell how far they have travelled till 9:45 am. And little Paheli had no answer to this question. They went to their teacher. She told them that one way to solve this problem is to plot a distance time graph. So let us find out how such a graph is plotted. So with this, we are on to our new topic of this chapter, that is distance time graph. So students, you might have seen that newspapers, magazines, etc. present information in various forms of graphs to make it interesting. The type of graph shown in this picture is known as a bar graph. Another type of graphical representation is a pie chart, or you can see in this picture. The graph shown in this figure is an example of a line graph, and the distance time graph is a line graph. So let us learn how to make such a graph. So for this, we will take a sheet of graph paper. We will draw two lines perpendicular to each other on it. Now as shown in this figure. Now students, we will mark the horizontal line as x, o, x dash. It is known as the x-axis. Similarly, we will mark the vertical line as y, o, y dash. It is called the y-axis. And the point of intersection of x, o, x dash and y, o, y dash is known as the origin O. So the two quantities between which the graph is drawn are shown along these two axes. We show the positive values on the x-axis along OX. Similarly, the positive values on the y-axis are shown along OY. In this chapter, we shall consider only the positive values of quantities. Therefore, we shall use only the shaded part of the graph shown in this figure. Now students, remember Bujo and Paheli? So both of them, Bujo and Paheli, found out the distance travelled by a car and the time taken by it to cover the distance. Their data is shown in this table. So now let us make a graph by following certain steps. So the steps are as follows, students. We will draw two perpendicular lines to represent the two axes and mark them as OX and OY, just like in this figure. Then we will decide the quantity to be shown along the x-axis and that to be shown along the y-axis. In this case, we show the time along the x-axis and distance along the y-axis. Then we will choose a scale to represent and another to represent the time on the graph. For the motion of the car, scales could be like time is 1 minute, which is equals to 1 centimeter, and distance is 1 kilometer, that is equals to 1 centimeter. Now we will mark the values for the time and the distance on the respective axis according to the scale you have chosen. For the motion of the car, we will mark the time 1 minute, 2 minutes and so on, and the x-axis from the origin O. Similarly, we will mark the distance, that is 1 kilometer, 2 kilometer and so on the y-axis, which is shown in this figure. Now we have to mark the points on the graph paper to represent each set of values for distance and time. Observation recorded at serial number 1 in table 13.6 shows that at time 0 minute the distance moved is also 0, and the point corresponding to this set of values on the graph will therefore be the origin itself. After 1 minute, the car has moved a distance of 1 kilometer. To mark this set of values, look for the point that represents 1 minute on the x-axis. Then we will draw a line parallel to the y-axis at this point. Then draw a line parallel to the x-axis from this point, corresponding to distance 1 kilometer on the y-axis. Now the point where these two lines intersect represent this set of values on the graph as shown in this figure. Similarly, mark on the graph paper the points corresponding to different set of values. Now see this figure, students. It shows the set of points on the graph corresponding to positions of the car at various times. Join all the points on the graph as shown in this figure. It is a straight line. Now this is the distance time graph for the motion of the car. And if the distance time graph is a straight line, it indicates that the object is moving with a constant speed. However, if the speed of the object keeps changing, the graph can be of any other shape. Generally, the choice of scales is not as simple as in the example given in the previous figures. We may have to choose two different scales to represent the desired quantities on the x-axis and the y-axis. Let us try to understand this process with an example. So students, let us again consider the motion of the bus that took Paheli and her friends to the picnic. The distance covered and the time taken by the bus are shown in the table 13.5. Now the total distance covered by the bus is 80 km. So if we decide to choose a scale 1 km is equals to 1 centimeter, we shall have to draw an axis of length 80 centimeter, and this is not possible on a sheet of paper. On the other hand, a scale of 10 km is equals to 1 centimeter would require an axis of length only 8 cm. So this scale is quite convenient. However, the graph may cover only a small part of the graph paper. So some of the points are to be kept in mind while choosing the most suitable scale for drawing a graph are the difference between the highest and the lowest values of each quantity. Second, the intermediate values of each quantity, so that with the scale chosen, it is convenient to mark the values on the graph and to utilize the maximum part of the paper on which the graph is to be drawn. Suppose that you are given a graph paper of size 25 cm by 25 cm. So one of the scales which meets the above condition and can accommodate the data of table 13.5 could be that distance will be 5 km is equals to 1 cm and time 6 minutes is equals to 1 cm. Now students, a question arrives that can you now draw the distance time graph for the motion of the bus? Try it and you will find the similarities between the graph drawn by you to this figure. Also students, distance time graphs provide a variety of information about the motion when compared to the data presented by a table. For example, table 13.5 gives information about the distance moved by the bus only at some definite time intervals. On the other hand, from the distance time graph, we can find the distance moved by the bus at any instant of time. Suppose we want to know how much distance the bus had travelled at 8:15 am. We mark the points corresponding to the time 8:15 am on the x-axis as shown in this figure. Now suppose this point is A and next we draw a line perpendicular to the x-axis at point A. We then mark the point T on the graph at which this perpendicular line intersects it, which you will see in this figure. Next, we draw a line through the point T parallel to the x-axis. This intersects the y-axis at the point B. The distance corresponding to the point B on the y-axis, that is OB, gives us the distance in kilometer covered by the bus at 8:15 am. So now students, can you help Paheli to find the distance moved by the bus at 9:45 am? Also try to find the speed of the bus from its distance time graph. So students, with this we are at the end of our chapter, and in this chapter we have learned a lot of interesting things. We have learned that motion of objects can be presented in pictorial form by their distance time graphs. We have learned that the distance time graphs for the motion of an object moving with a constant speed is a straight line. So students, now it's time for some exercise portion also, so that we can strengthen our concept learned in this chapter. So the first question is, show the shape of the distance time graph for the motion in the following cases. The first one is a car moving with a constant speed. So here in this image students, you can see a graph. And the second one is a car parked on a side road. So students, in this graph you can see a distance time graph for the car parked on the side of the road. Moving on to the question 2, that is, which of the following relations is correct? The first is speed is equals to distance time. Second is speed is equals to distance divided by time. Third is speed is equals to time divided by distance. And the fourth is speed is equals to 1 divided by distance into time. So the correct answer is students, the second option, that is speed is equals to distance divided by time. Moving on to another question students, that is, suppose the two photographs that are shown in this picture of NCERT had been taken at an interval of 10 seconds, and if a distance of 100 meters is shown by 1 centimeter in these photographs, so can you calculate the speed of the blue car? So students, its answer is 10 meter per second or 0.1 centimeter per second. Now moving on to the question 4. Now in this figure, it shows the distance time graph for the motion of two vehicles, that is A and B. Which one of them is moving faster? So students, it is clearly evident that vehicle A is moving much faster. Moving on to the fifth question. Which of the following distance time graphs shows a truck moving with speed which is not constant? So students, among all these options, which one shows the graph of the truck which is moving with a speed which is not constant? So we can clearly see that the answer is the third one. With this students, we have completed our chapter. I'm sure that you might have enjoyed this chapter. Also, try to practice all these exercise questions and try to perform these small activities as well. We will meet some next time with some other interesting chapter. Till then, bye bye.